This is Steve Piloff from George Mason University. So sometimes we've got an annuity or annuity due, meaning we're going to be making regular savings payments. We know the future value, so we know our investment goal. We know what the amount is that we're going to be saving at regular intervals, and we know the number of regular cash flows. So that means we also know when we need to meet this goal and how many of these we're going to be saving, and annuity or annuity due, whether we start immediately or in one period. Um, and if we've got something already at the reference point, often it can be a special extra savings at time zero, but most commonly it's amount already saved. And what we want to do is say, okay, given that we've saved this much or don't have anything saved, and given that we're going to invest this much every period and we want to retire or have our kid go to college with so much in the account at this point in time, what's the rate of return we need to earn? That's a common problem, and that's one that we can address. And as usual, the financial calculator is a very useful tool because otherwise it's very cumbersome and in fact can sometimes be impossible to do it algebraically. So the idea with the calculator is you are going, or we are going to tell the calculator all the cash flows, and we are going to tell it the future value, and we're going to tell it when we want to hit that future value, which also tells it, how many cash flows there are, and it will find the interest rate that makes those things work together. So notice we switch things up a little bit. We're starting with the begin mode, and we tell it N, and we tell it payment, and it says, aha, there are N payments starting right away. 1, 2, 3, 4, and there's your nth. You tell it PV, which would be some extra payment at time zero, or more commonly, the amount currently in the account. You tell it FV, so it knows that's the future value as of time N. And we'll solve for I% to give the interest rate such that all of these savings compounding at that rate will get us to the FV. End mode, very similar. Notice the PV is still at time zero. There's N payments. It's just that now they start in one period and therefore end in N periods. And so you make your last payment and you say, how much money do I have? And you have your future value, your target goal that you told the calculator, and we'll find the interest rate that you need such that these cash flows will get you to that future value. So let's take a look at a few examples. Down payment of $30,000, and you want it in 8 years, and you can save $2,900 per year for 8 years. So you know you're going to be making 8 savings payments. We haven't established when they're going to start, but now we know your first is in a year. So first, second, third, fourth, fifth, sixth, seventh, eighth. So as soon as you give them $2,900 in 8 years, you want $30,000 back from the bank. What rate of return must you earn? So what is R such that 2,900 times 1 plus R to the 7th, notice it's 7th because we start in 1 year and get to 8, plus 2,900 times 1 plus R to the 6th, plus 2,900 times 1 plus R to the 5th, all the way out to plus 2,900. What's R? So that the sum of these 8 individual future values would equal 30,000. Well, use the calculator. N payments of 2,900, contributing 2,900. When do we start? In 1 year. And then there's 8 of them, so in 1, 2, 3, 4, 5, 6, 7, 8. We want 30,000. We got nothing saved. What do we have to earn? 7.23%. A year, you put in 2,900. For 7 years, it'll compound at 7.23%, and then it'll be worth something. 2 years from now, you're going to also put in 2,900. That'll compound for 6 years. All 8 of the contributions you'll put in your last one. It won't compound all because you'll say, here's 2,900, now give me my money. The bank would give you $30,000. Here's a similar 30,000 needed in 8 years, 2,900 per year for 8 years. But now your first payment's later today. So 1, 2, 3, 4, 5, 6, 7, 8. So now we need the R such that 2,900 times 1 plus R to the 8th plus 2,900 times 1 plus R to the 7th, all the way out to our 8th contribution of 2,900, which would happen in 7 years from now. We'd go to the bank, we'd give it to them, and instead of saying give us our money, we'd say, we'll be back in a year. So it would compound. So when we showed up, the 2,900 that we gave here would be 2,900 times 1 plus r. And at that point, at time 8, we would get 30,000. So what rate would we need to earn in this case? Well, we're going to be making 8 payments, but we're going to start immediately, and those contributions are going to be 2,900. In 8 years, we want to have 30,000. So what rate would we need to earn? 5.69%. So it should make sense that in both examples that we've looked at, it's 2,900 for 8 years, but if we start saving today, the rate we need is less than if we wait a year. So, the message is the earlier you get started saving towards a goal, all else equal, the lower the return, which translates into the less risk one would need to take in order to expect to meet a goal. Finally, you have $100,000 saved. $5,000 per year for 30 years. So $5,000 in the account. First savings in a year, so the first one's in 1 year, second being 2, third, last one's in 30. You want to retire in 30 years with $2 million. So we want to have $2 million in 30 years. What rate do we have to earn to meet this goal? So we know the 100,000, compound 100,000 times 1 plus r to the 30th. A year later we put in 5,000, and then that would compound to 5,000 times 1 plus r to the 29th, 28th, 27th, all the way to our last 5,000, where we go to the bank and say, here's $5,000. Now can I please have my money? And they would give you $2 million. What's the rate that's going to help make this initial amount plus these 30 payments all compound to $2 million? Well, we can do this in one step because we've got an initial amount, and from PV to FV, the amount of time that the PV to FV, or from 100,000 to the 2 million, is 30 years, and we're going to have payments for 30 years, so n is 30 in both cases. So today we have 100,000. In 30 years we want to have 2 million. We're also going to be paying $5,000 into the account for 30 years, and we're starting in 1 year. What's the rate that all these things need to earn in order for us to hit our 2 million? 8.98%. So the 100,000 would compound for 30 years at 8.98, and then we just keep adding 5,000 every year, and whatever's in the account, 8.98% for the next year.